Didn't say much. All right. Yeah. So thank you to everyone who did some work on Thursday. I appreciate it. We're going to revisit those questions later. I didn't get a chance to really look at them yet. How did we feel about the multiple choice that I left? Anyone? Pretty good? All right. Some of them we didn't know what to do, and that's totally fine. I just threw a review at you just to kind of figure out where we're at and what things we need to start reviewing. As you may know, Unit 5, I've mentioned it, but Unit 5 is going to be our last unit that has to do only with derivatives. So we're going to kind of stop with derivatives and do something else called integrals. So we're moving kind of from the A part of calculus to the B part, which is very exciting for me because I like the B part a lot better. So that's going to be pretty exciting. So we're going to start doing a little bit of AP review as we move forward, some of those multiple choice questions. And Unit 5 is going to collect kind of a bunch of derivative stuff that we just generally don't use in the grand scheme of like all of our max min stuff. So some of these gross functions. So today we're going to learn 3 new derivative rules. We're going to combo those with the 2 we learned at the very end of last class when I was here. This log rule, log base A, and the base A exponential as well. That's okay. We'll review them. No worries. I know it's been a while. So we'll learn one of these rules first. It's going to be just for generic inverses. If you hate this, it's for literally one multiple choice question on the non-calculator multiple choice. It's usually number 28, 29, or 30. So let me know this year if I am correct. Does anyone know like 2 functions that are inverses? Meaning if I do them to each other, they kind of cancel out. Example, what happens if I take the square root of x and then I square it? I get x, right? What's another example of 2 functions that kind of undo each other? Ooh, okay, so we could do like, yeah, I don't know how to compose those, but like 1 over x, and we could do like that to the -1, so -1 power. What else? Ooh, my favorite too, natural log and e to the x. I could do e to the natural log of x or natural log of e to the x, fancy twin over there using my favorite functions, and I get x. The idea is if I have 2 functions that are inverses and I do what's called composing them. So I have f of g of x or g of f of x, I will get x out of them. They kind of undo each other. Now there's some caveats to that. Like if I do the square root of x squared, I don't necessarily just get x, but for the sake of argument today, we're going to do that. Does anyone know, you learned this in Algebra 2, hopefully, what line these reflect over if I graph them?
I don't remember.
Yeah, it's y equals x. Do you remember in Algebra 2 to find an inverse, you like flip-flop the x and the y, and then you like solved for y again, I think? So these, if you graph them, will reflect across the line y equals x, just because it's easy to draw. Here's a e to the x, your exponential. He gets really big really fast. Natural log of x looks like this. I'm just giving you some pictures here if you care. And here's that line y equals x. Now that's a really terrible picture because I'm hand drawing, but all of your graphs will reflect across that line. One kind of really important conclusion from that is if I have the point a comma b on my regular function, what is on my inverse function, which we're kind of calling b comma a. And that's really the most important point that I need you to remember about inverses is you kind of flip-flop the x's and y's. So I'm going to be reviewing some derivative rules to give us 3 new kind of memorized derivative rules today. And this is the first one. So I'm actually going to peel this guy down here to get me my new derivative rule. I'm only choosing this part of it because I know it's going to give me the rule that I want. So I'm not choosing this one. I'm choosing the g of f of x because I know it's going to give me the rule that I want. Kind of the textbook. Because I've read a textbook before. So I'm just trying to mirror the language that would be in a textbook or in any other rule that we're going to look at. You're going to get a very similar rule. It would just flip-flop the F's and G's. I'm just trying to reflect what you would see if you looked online at a resource. Hello. So I'm going to take this guy right here, and I would like to take the derivative of both sides of this. Can you look at this side of it and then whisper to your neighbor the derivative rule that we will probably have to use to take the derivative of that side? Oh, that's really loud whispering, but I like the answer. Chain rule is the correct answer there. Anyone remember how to do chain rule? All right. So G prime. Do I leave the inside function alone? So like f prime of x? All right, an easier derivative. What's the derivative of the other side, the derivative of x? 1. All right, I would like to identify the derivative of f of x here. So I'm going to isolate that by dividing by this big thing that's on the left-hand side to give myself a rule that I'm going to kind of memorize. Now, you can certainly derive this rule. It took us about 2 seconds to do right now. But if you have space in your noggin and you feel like definitely getting one of the multiple choice right on the AP test, here's a nice rule, and I'm going to show you how to use it. So today, it's going to be kind of the same pattern all day. I'm going to show you how to get a rule that ideally you will memorize, and then we're going to talk about how to use it. So there's our first rule of today. Like I said, this is always a multiple choice question. It is always a singular multiple choice question, and it's always put towards the very end of the non-calculator section. That section's pretty long. They don't know if you're going to get to it, and if you get to it, great, whatever. If you don't, you were probably going to get this question wrong anyway, because it's a very singular rule. So f prime of x is 1 over g prime of f of x. So we're going to talk about how to put the pieces in there. So let's talk about what this question is going to look like, how I know to use this rule, and then how to use the rule in general. So one thing that's going to tell me I want to use this rule is I'm going to have 2 functions in my question. So here I have f and g. They could look like f and this guy here called f inverse. Or they could just come right out and say, hey, I want you to know that g is the inverse of f. We really don't use the word inverse for anything else in calculus. So if you see the word inverse, this is what you're doing. And then they give me some very discrete pieces of information. They give me 1 point, they give me a point on the derivative, and then they ask me for a point on the derivative of g. So if you have this question, this kind of formula memorized, what I'm going to do is I'm going to replace the x's with -2's, because that's usually what's here. And if you notice, since I'm trying to find g prime, I'm going to replace the f's with g's and g's with f. So kind of doing my inverse thing. So I'm going to do 1 over f prime of g of -2. So one thing that should match, this and this inside should match, and this should be your other one. Ooh, okay, Herbie's already going on. So essentially this question is like a scavenger hunt now. You either need to see if they're giving you outright the information or if you need to find it. So Herbie claims that g of -2 was 5. That was given to us in the question. And I like that he's kind of peeling this from the inside out here. So not like an onion, but oh well. Like an inverse onion for inverses. There we go. So we replaced g of -2 with what we knew it was, 5. Now, did they tell us what f prime of -5? Yeah, they gave that exactly to us too. So that's -1/2. What is 1 divided by -1/2? -2. You want to flip that guy? Our answer is E. And we're done. Yeah, so as long as you can make this jump, the question's really easy. If you can't make that jump, the question becomes really hard. So let's try another one. Here again, we've got G and F. They've told us their inverses this time through this statement. They're saying F is the inverse of G. Again, we've got some discrete pieces of information. We've got F of 2 is 1, and we've got G of X is this function, which is a little bit more interesting. All right, we're looking for F prime of 2. So I'm going to do 1 over the other function prime at the same function, same x value. All right, what should we try to identify first? F of 2. Anyone see it? It's 1. All right. Did they tell me what g prime of 1 was? Darn it. All right. Well, they gave me g of x. G prime means take a derivative, right? Could I take a derivative of that? Is Herbie right, y'all? Three plus 1 is indeed 4. So I can do 1 over 4. Done. Woo! Pretty much. Yeah. So here's the hardest version of the question that I've seen, and it has to do with tangent lines. So a little bit more application, a little bit scarier answer choices. But let's talk about how to use this question. First of all, I noticed there's no function, so I'm not really going to have to do any calculus like I did in number 2. I'm really going to just be kind of pulling this scavenger hunt thing off like we did in number 1. So again, language, we've got F and G both in this question, and we've got this key statement right here that they are inverses. I have F of 3 is 5, F prime of 3 is 7. But when they start asking me about this tangent line, they're asking me about the graph of G and not the graph of F. I know to write a tangent line, I usually need 2 things. What are those 2 things? A point and a slope. So I'd like to know G of something equals something and G prime for the slope of something equals something. So let's start with, I don't have G of anything equals anything. Can anyone think of a way to get a point on G? It's a very vague question. I'm hoping for a super specific answer. Explain. I think yes.
So like we have F of 3 equals 5. Can we have G of 5 equals 3?
Brilliant. All right. Does everyone see what Matt's talking about?
Oh.
All right. This is like the only thing about inverses from algebra 2 we need to remember. What a brilliant, brilliant observation. Since we have 3, 5 on the graph of F, we have 5, 3 on the graph of G. That's helpful because I can actually already cross out some answers. Anyone see an answer that we can get rid of? I think there's at least a couple. Which ones? Yeah, I don't like B at all, personally. Ooh, yeah, I don't like B either. Because of that 1/3, the 1/5. I also don't love this X is 3, right? Is X going to be 3 if this is a tangent line to G? No, what should X be? 5. So I actually know it's not A either. I am down to 2 answer choices. Hell, heck yeah. Shouldn't say hell in class. All right. I do have to find the slope. So I can do G prime of 5 is 1 over opposite prime G of 5. You can probably already guess what the answer is going to be. Do you think it's 1 over 7? All right, I can go through the motions of this. G of 5, like Matt told us, is 3. F prime of 3, they gave it to us, is 7. But I would also probably guess that the slope isn't the slope that they gave us because we're talking about the inverse function. So I'm going to go with E. So a little bit more creative, but not too much actual calculation involved. All right, I would like to, that's pretty much it for derivatives of inverses. It's a very specific question. This is one of those, if you're planning on trying to get a 5 on the AP test, this might be your jam. If you're planning on just maybe doing well on the Unit 5 quiz, maybe remember it for a little bit. Speaking of other things, what? You forgot about the AP test?
Yeah.
Why?
Well, I forgot I was supposed to be remembering everything else.
That's fine. We're going to review. We're going to be, when are we going to be done?
I really
That's BC. Theoretically, I'll be done teaching you by spring break. So it's going to be good.
So when we
review for the AP test, even if we're not taking the AP test. And then juniors will probably start learning BC after the AP exam. So you can see if you like it. In a very sheltered, friendly way.
It was Emory. Every meeting.
Wow.
I can't believe you're real.
All right. I would like to show you these two rules and then take a break. How does that sound? How about 5? Because we have things to learn, Matt. You remember the A in your AP stands for advanced. Advanced people don't take breaks. All right, so I want to preface this page by saying I'm trying to show you 2 rules that eventually you're going to memorize. Yes, we'll talk about what those things mean. So the math that I'm going to show you to get these rules, one, I think you deserve to know because you would not predict what these derivatives are if I gave you $1 million. You would not predict what they are. So I think you deserve to know why the rules are the way they are. Also, the math involved to making these rules is really good and will help us review. Why are we just chilling on our phone? Can we put our phone away? The math involved is really cool, so I want to show you that as well. But eventually, moral of the story, you're going to memorize these 2 rules. So let's see if we remember anything about trig. So this guy right here, has anyone seen this notation before, arc sine? Okay, have you seen this notation? Okay, those are the same thing. It's like the only thing that the AP test will remind you is those notations are the same thing. I have a strong preference for the arc notation because in calculus we have a heck ton of stuff that looks like exponents. Arc, that's a great question. In my mind it stands for like inverse sine, but I don't know why they use the word arc. I'll look it up while we're on our break. So here, these guys are the same thing. Most of the time I will use this notation, and for the past quite a few years, the AP test was preferring the arc notation. More recently, they've pulled this out again. Just know that those are the same thing. So what that means, arc sine and sine are inverse functions. They kind of get rid of each other. So I don't know what the derivative of this is right now. I'm trying to find it. So what I'm going to do is I'm going to apply sine to both sides of this. Sine and arc sine are inverse functions, so they get rid of each other. So I get the equation sine of y equals x. What? So sine and arc sine, kind of like squared and square root, they get rid of each other. They are inverse functions. They do exactly the opposite thing.
Is arc sine equal to sine?
Yes.
Oh, I thought that was it.
All right, so let me write this in a different way so we can. That. So what I'm doing is I'm applying the sine x to both sides. So I'm saying, ooh, that is too sad. Sine of y equals sine of arc sine x. These guys right here are inverses. So just like if I took x squared and square rooted it, or e to the x and did natural log of that, those are canceling.
Wait, so this inverse. Is the next one going to be
Mm-hmm.
so like just normal functions?
So arc sine is like a function in and of itself. Yeah. It's just like an easier way to write this.
Like arc.
That's not a thing. Yeah. All right. We all comfy now, or at least semi comfortable. on the same page, in the same ballpark. All right, my goal eventually is to find dy dx. I would like to find that. So I need to take a derivative. Here, we can take a derivative because, good review, we can take derivatives of things with y's in them. Anyone remember what we have to do if we take a derivative of something? There we go. All right, so sine of y. What is the derivative of regular sine? Cosine y, and then I'm going to multiply it, like Matt said, by dy dx. So it's like a chain rule. Equals 1. Where's Derek getting the 1? Derivative of x. Perfect. All right, now I need to figure out what cosine of y is. So I'm going to travel to this triangle for a second. Kind of has a little bit of a related race feel. And we're going to do some like geometry review. So usually things we take the sine or cosine of, those are usually angles, right? So I'm going to put y here. And I'm going to make sure that when I label this triangle, the sine of that angle is x. So, remember SOHCAHTOA from geometry? Which one was sine? Opposite over hypotenuse. So I'm going to put x and 1. Because these are angles.
How do you know that exact?
It doesn't matter. It just shows me. It can't be the right angle, but you're right, Herbie. It could be the other one, so I'm just choosing one. So would you agree with me that now if I took the sine of this angle, here's my opposite, here's my hypotenuse, so x over 1 would equal x. I could do 2x and 2. I could do 4x and 4. The easiest way to do it, though, x and 1. You cool with that? I just chose that one. I can't choose the right angle, but I could choose the other one. You're right. All right. So I would like to find cosine of y. How do I find cosine, SOHCAHTOA-wise? Anyone seeing a problem? What the heck is it? How could I find it? Ooh, okay. So do you guys mind if I use question mark as a variable? All right, so I'm going to do question mark squared plus x squared equals 1 squared. Did I set that up right? All right, so I'm going to do question mark squared is 1 squared, yes, is 1 minus x squared. And how do I get question mark by itself? You mean square root it? Read your mind. Okay. Can I square each thing individually? Or do like 1 minus x? No, please stop doing that. All right, so that is what question mark is. This is square root of 1 minus x squared. Yeah, a little complicated, I agree. What? Would you like it to be a different variable? No, okay. Oh, gotcha. Yeah, gotcha. All right, so let's do cosine. Cosine is supposed to be, remind me again, what's cosine on the triangle? Adjacent over hypotenuse. So this square root weird thing over 1. I still have my dy dx, and I still have the 1 on the other side. Yeah, perfect, Sadie. I'm going to take this, and I'm going to divide on both sides. So I'm going to get 1 over the square root of 1 minus x squared. That is my derivative of arc sine x. If I had given you $1 million, would you have predicted that? All right. I think it's super crazy weird how it goes from like a very trig function. Yeah, you would have. Would you like to predict arctangent then? I think it's super crazy that it goes from like a trig thing to a very algebraic thing. If I go down and travel to the rule that I'm going to write down here, notice I have a U here. Anyone think they know why I put a U there? It's a reminder to use a rule. Yeah, this is a reminder to use chain rule. So here, I'm going to do 1 minus u squared on the bottom. And just like we've talked about with log a lot, with all of our log derivatives, I'm going to save the numerator where that 1 has been sitting when we made this rule to put my chain there. So this is going to be my derivative of the inside. So if you hated how we made that rule, that's okay. Really what we're going to need to do is be able to use this rule after we memorize it. So some good math that we're reviewing, some implicit differentiation, but really at the end of the day, we need to memorize. So I think so, actually, kind of. Yeah, so all right. We're going to do this one, then we're going to take a break. So similarly, I'm going to apply tangent to both sides. Matt had asked me earlier, but if I do tangent to both sides of this, just the way the signs did, these this tangent and this arctangent are going to effectively cancel out. One is doing exactly the opposite of what the other is doing. So I get this. All right, derivative rules. Who remembers the derivative of tangent? Okay, secant squared, y. What has to go after that before my equal sign? dy dx equals, question mark? Got to take my derivative, so 1. Now, I remember that we were using like the right triangle trig to try to evaluate some of this stuff, and I don't really like doing right triangle trig with secant as much. So I would love to divide by secant on both sides, personally, because it's going to give me a better trig function to work with. Yeah. What is 1 over secant? It's a different trig function. What was your first letter?
O.
Sine. Yeah. Yep. So I'm trying to move this to the other side by division, because I remember when we were going through up here, we were using some right triangle trig, and we don't usually evaluate secant as much. So I thought it might be better to move it as cosine. 1 over secant is equivalent to cosine. Yep. All right. Let's go back. We're going to right triangle trig. All right. Still going to put this y there. You guys comfy if I put it here? I could put it here if I wanted to. I'm just choosing to put it there because it's not the right angle. All right. Tangent. SOHCAHTOA some stuff. Opposite and adjacent. So x and 1. Will that give me tangent y equals x, like my thing says? Good question. All right. You said tangent was opposite over adjacent, right? If I have 1 and x like this, is tangent y equal to x? Opposite over adjacent? No. So I can't just flip those. I could do a different pair though, theoretically. So I could do like 2x and 2 if I wanted to. I'm just choosing the simplest way I know. All right. What do you think we're missing? Can you find it for me? Find me the hypotenuse. Okay, we could do a different letter. I'll do my favorite letter. Do a theta.
No. Why you
Go back. Delta? Uppercase or lowercase? Uppercase? Lowercase? Delta? Delta? Yeah. Just want to make sure I have the right Greek letter. I could teach you the epsilon delta proof of limits. That did any of you do that? Epsilon delta. They would call it by that name. It's back in limits. It's very proofy. They probably wouldn't make you do it. You find like a little Y window, little X window. There's a really funny YouTube video of it where these guys have gloves and sunglasses and they sing this song. It's really strange. All right, has anyone found the question mark yet? Wow. Nice. All right, Johnny's got it. So I'm just doing square root of 1 plus x squared. Again, here I cannot distribute the square root.
If you just kept it like that first one, why can't you just square root of x?
What?
1 plus x.
Because I can't distribute because of the plus. So I can't square root each thing individually. It did not.
1 squared is equal to. Because 1 squared is.
Because 1 squared is 1. Because if I took 1 plus x and quantity squared it, I get this 2x in the middle. That's why it's not legal.
Oh.
All right, let's go ahead and plug in. I had dy dx. All right, this squared just means I'm going to take the fraction for cosine and square it. Remind me, what is cosine on our triangle? All right, so adjacent is 1. Hypotenuse is this thing we found. Why? Yes. So legal things I can do. Does everyone see what Sadie's talking about? This square root and this squared, I can make those cancel out because I can square the top, square the bottom. So I'm going to have 1 on the top because 1 squared is 1. This square root quantity squared is 1 plus x squared. So we're trying to find a derivative rule. So eventually we're going to be asked to like find the derivative of the function, do a tangent line, something like that. I agree. I didn't do a very good job saying the rules for this page. All right. So again, I'm going to do 1 plus u squared because most of the time these are going to have a chain rule. And I'm going to put my chain on the top. So moral of the story, as we kind of go into our break, I just want to tell you where we're at. Will I ever ask you to do this? Absolutely not. But I think there's a lot of math that was good and good review there. That being said, what we're going to have to do, kind of going off to Sadie's question, is we're going to be taking derivatives of functions that look like this. Now notice none of them are just like arctangent of x. They're like arctangent of 3x. Yeah, so it's just a really extensive use of chain rule in effect. So we're going to do a bunch of these questions towards the end of class, and that's kind of how we'll finish out, is just remembering how to use these rules. This is going to feel a lot better when we do it together than it will when you start to do it on your own, just because I've had like 20 years to remember what the derivatives of these are. Not 20, I'm not that old yet, but closer to that than I would like to admit. So we're going to practice using these when we get back, and then towards the end of class, we'll start a notes check that will kind of put all of this stuff together. So I've been talking for a heck of a long time. Let's take 5 hours. Stay in here forever. Yeah. Bye. So I'll post the recording, Johnny. I don't know if we'll be able to finish this notes check, but we'll at least start it. Do you want a copy before you leave?
Not really.
Okay.
I don't want to look at it.
Yeah.
No. But we have a 4-day weekend.
That's fair. But then, like, March is just like,
That's my birthday weekend, so I'm okay with it.
nice. My birthday is always at the end of the first quarter.
I'm older.
What? No. I figured not, because that's more of like it's definitely like a proofy thing. Yeah, it's such a weird proof to do because it's like if you can find this, then you have to. It feels very wishy-washy. His class is super pretty. You guys are probably having the same experience I had. I had an engineering friend in college, and we were taking like all the exact same classes, but I was proving everything that he was using, like applying. Yeah. Proofs are cool, but they're just frustrating. They're cool when you can figure them out. They are not cool when you can't. That's fair. It's just more so like with proofs, you can't really do anything about it. You just have to like think more. Yeah. I would carry paper a lot more places because you'd be like thinking on your way to class and be like, oh my god, I figured out how to do my homework. I should probably do attendance. What? Do they have cool letters for variables? Do they make more sense than theta? Because no one likes theta. I love theta. Everyone gets so creeped out when I use theta. Oh, yeah. What time is it out here today? Oh, it's Monday. It's a weird time. One 105? Oh, sick. I'm so excited to start integrals in here. The best opening activity ever. That looks like a butt. I used to draw my infinities by drawing two circles next to each other, and my one of my first students was like, "Vakin, you can't do that anymore. It looks like a butt." I was like, "Take you're right. It does look like a butt." So I used to do handwriting projects because I used to do all of my R's were uppercase R's. One was just like bigger than the other one. To be fair, I don't really know the difference between them. All right, let's finish up these notes so that you guys have a lot of time to work on your notes check for today, because I actually really like the notes check I made. What we're going to do is we're now going to do the part of like this that you would need to be able to do theoretically. So how do I use these two rules and apply it to taking the derivative of the function? So I apologize, Sadie. Again, I didn't really do a good job at these directions, but imagine the directions are like take the derivative of these functions. So I'm going to be looking for dy dx, y prime, f prime, whatever you want. I have kind of an order that I write all of these down, so I'm going to be showing you that just because it makes sense in my brain. If you hate it, do whatever you'd like. I'll give you some options. Notice here, though, that we kind of have very similar looking derivatives. I always think looking for patterns is a lot easier. So when I think of these derivatives, the things I think of are which one has the square root and which one has the plus or minus. So you'll notice the sine one has our square root and our minus. Our tangent has the plus. Notice too that you could theoretically reverse the orders of these two if you want, but I usually keep the u squared at the end just because it is in both of them. So it's just kind of easier for my brain to pick up on the patterns that way. So here's kind of how I go about doing these. So I have my function is arctangent of 3x. First thing you're going to want to do is identify whatever kind of that inside function is, or whatever our u would be in that formula. This is our inside function. Let's find out. So the thing I like to do first is actually the denominator, because that's where most of the work is going in these tangent, arctangent, and arcsine questions. Arctangent is the one that does not have the square root and has the plus. So I start with 1 plus and put some parentheses squared. I think I heard Herbie say he was going to put 3x in there. Do you guys agree with that? All right, so 3x goes there. And I heard him put a number in his numerator. What number did he put there? 3, that's coming from the derivative of 3x. Now, if this were just like a free response question, or if I just asked you to take derivatives, said you don't have to simplify it, you're more than welcome to leave it here. What I am going to do is start simplifying some of these just because it's probably going to be a multiple choice question. What could I write instead of quantity 3x quantity squared? 9x squared. Now, one thing you want to be careful of, my BC students, when they were using these functions this year, kept forgetting this set of parentheses like crazy. This, my first line, is wrong currently because that squared only applies to that x. So please do be sure that you're either simplifying or you're using those parentheses correctly. I'm squaring this 3. What? Matt, you good? Okay, Sadie? So this arctangent, you can think of all as like one function. So the arctangent told us that we were doing this like big old fraction thing. Kind of like the natural log, we knew we were doing like the derivative over the original. We're just using our rule. All right, so here again, notice that we could encounter this type of kind of notation for our arc sign. If you like the arc better, you're more than welcome to rewrite like this. You could even throw some parentheses on there. And just like Sadie's question, this function or this notation is telling us what rule we're using. So just like the derivative of regular sine is cosine, the derivative of arc sine is this weird, nasty thing that we just figured out up here. So what I like to do again, I'm going to call the derivative y prime. I like to start in the denominator. Since we're working with arc sine, that's the one with the square root, right? Yes. Yes. 1 minus. So when I see arc sine, I've got my square root, I've got my minus. Because that's the formula for arc sine. Remember, we did have the hypotenuse there when we Pythagorean theoremed all our stuff. All right. So x squared is going to go inside here. Herbie's right. It's going to eventually be x to the 4th when I simplify. What am I missing? Yeah, my stuff on top. All right, my derivative on the top will be 2x. That's coming from the derivative of the x squared. So notice I'm taking the derivative of the thing that goes inside that squared, not like the derivative of the x to the 4th that Herbie's talking about. So if I wanted to simplify, the only thing is just to square that thing that's inside there. I could multiply those exponents to get x to the 4th. And all of it yet. Yeah.
So what happens if you keep the 1 minus x squared squared?
That's a great question. So if I were asking on a test, and I probably won't ask you to simplify on a test, so that would be totally fine. If this were on the AP exam, I would imagine it would be a multiple choice, so you would just have to be able to match that to the answer choice.
But the answer choice was
Probably. I've seen some unsimplified, but most of the time they're all right, let's try a couple other ones. Maybe I'll have you guys try a couple. All right, some questions now. Arc sine, I see. Does that one have the square root? You can do y prime. I'm just trying to mix it up so we are familiar with all of them. The only time I would say you have to do dy dx is like if in the question they're like, hey, find dy dx, then I would make sure you're matching notation. Arc sine, is that the plus or the minus? Cool.
Well, technically, it's a plus.
Lies, because I'm going to square that -2. All right, -2x squared is going to go in there. What will go in my numerator? -4x. If I simplify this one, -4x is just going to stay there. Nothing's coming out of the square root. Keep in mind that the squared will square the -2 to make it a +4. And I will square the x squared to get x to the 4th. That minus, though, will be preserved because I squared the negative before. All right, let's try one more together, and then I'm going to have you guys try some on your own. Love people. All right, our tangent. Square root? Do I have the square root?
No.
Oh,
Sorry.
it's fine. I'm acting. I know what the answer is. Yes, the original inside is going to go here. You guys like it?
Yeah.
Now, for something like this, I would personally probably not simplify this, and I imagine, kind of going off of what this table's been asking, I would imagine they probably wouldn't simplify it in their multiple choice either, because this would have to be like FOILed out. So there would be 3 terms from there, and then the +1 would be a 4th term on the bottom. I imagine they wouldn't factor it out or like FOIL it out to multiply. So I would probably just leave it like this. All right, let's see if you guys can do a couple. I would like you guys to try just the next 2.
I was gonna ask about that.
You can try if you want. That'd be a good extension. So why don't you guys try h of x and this y with the e to the x on it. If you're feeling spicy, try to simplify the denominator of the tangent one. I'm going to give you guys, let's try like 3 minutes. That's probably all you need. Just the 2. Just these 2. We'll talk about G and the other couple together. It's feeling super spicy.
Should I add the one to the 25?
I would. In the denominator?
Yes.
Yeah, so I guess you could simplify one more time because you have the 2 in the top.
Oh, yeah,
You factor out if you wanted to. That'd be super spicy.
This is.
I love it when it's
What's up?
We don't have to worry about the triangle side, right?
No. So the reason we did that, I think the implicit stuff is a really good review because we don't use that a whole ton all the time. So I wanted to go through that. Also, there's just a little bit of good trig in there. I wouldn't ask you to actually do that because setting up the triangle.
Never get a question like this on
No. But I there's a lot of rules. I'm gonna say there's a lot of rules that like I don't show you how you get them. But this one, it just always bugs me how different it looks from the function. So I think you guys deserve to know. Because if I just told you like this is the rule, you'd be like, why? Why the heck is it that? So I think it's worth the time to go through. No. So ideally what'll happen, Satya, is you'll kind of have this memorized. So if you can do what we're doing on the last page, then you're good with what you need to be able to do. All right, let's talk about a couple more of these, and then I'm going to send you guys on your notes check. Did anyone foil out the bottom of this? All right, I got 4x squared, what was it? 10x was 20x, and then I had plus 25, so with the 126. If you kind of try to simplify this. If you didn't, no worries. All right, so you could also simplify like this. So Herbie kind of factored a 2 out of the denominator and canceled those. Totally legal, kind of interesting. Would they do that on the multiple choice? Maybe, who knows. For this one, I thought this one was kind of cool. E to the x is my favorite function. So I put e to the x there. What is the chain rule piece of that? What's the derivative of e to the x? Yeah, e to the x. All right. Yeah. So think of 2x plus 5, 2x plus 5.
Oh.
Yep, just FOIL. And then the 26 is coming from the 5 times the 5 and then the 1. All right, one simplification question here. What is this equivalent to, the stuff in yellow? What do I do to those exponents? What do you mean? It's e to 1 exponent. What is that 1 exponent? 2x. You would multiply those exponents. All right. The last few questions, maybe I'll just do a couple for you really quick, are just an illustration that I can make these very, very gross very, very fast. So if you look at g of x, the reason this one is a lot grosser, let's look at it. Yeah, it has an extra exponent. So I've got sine is my outermost function. I say outermost because there's multiple outer functions. Cubed is next. And then x to the 5th plus 1 is totally on the inside. Now, will I give you a question like this all the time? No, I will barely ever give you a question that's this bad, but let's think it through. Yeah, that could be a great bonus. So the outermost is my inverse sine, so I'm going to set that up. That one's got the square root and the 1 minus. The thing that I'm going to be squaring is now a thing with an exponent. So I would have x to the 5th plus 1 cubed. And then for the derivative on the top, I'm working with the cubed and the x to the 5th plus 1. So derivative of something cubed is 3, that's something squared, right? It is chain rule. So what should I multiply by? Yeah. So I can make it really gross really fast. How could I simplify this? I don't know. I might take the 3 and then I might take the 3 and the 5x to the 4th to make them 15x to the 4th. I'd probably leave this factored because I don't feel like foiling it all out. Multiple choice is probably going to combo those exponents on the bottom to give me x to the 5th plus 1 to the what power? Try again. Try again. 6. Multiply those. What? Where's the plus 3 coming from? So I'm keeping that as an entity together because I don't feel like foiling it out. So I'm just keeping it. So I'm just combining this bad boy and this guy. All right, last one. I'm just gonna do the bottom one because there's a kind of cool simplification. This would be a great bonus question. Hint, hint, nudge, nudge. All right, we've got another 3 layers. We got a cosine, we got an arc sine, we got an x squared. So first layer cosine. What's the derivative of cosine? Let's go with negative sine. Leave the rest of the inside alone. Very cool. Do you know about the derivative of arc sine? Do they teach that in Europe? Is that the one with the square root or no?
That's a square root.
Is it plus or minus? Cool. All right. We're missing a numerator. Anyone have strong feelings on it? 2x. All right. The only reason I wanted to show you this question, anyone see anything cool? What? Look at sine of arc sine. Those go away. I'm left with negative x squared times 2x. Remember this. And I could combo those numerators, negative 2x cubed. Look at this. So just cool algebra can happen. Cool trig. Can't do anything else to it, but there you go. All right. Now, you may be like, why are you teaching me all of these derivative rules? I hate them, and I don't like you very much. Well, yeah, sometimes. We are going to do 2 more things this unit, and they are way cooler than just learning random derivative rules. One is called L'Hopital's rule. It's named after a Frenchman. It's going to be a way that helps us evaluate limits that, remember limits way back in the beginning of the year? It's going to make all of the limits where it was stuff you didn't want to do. So like factoring, conjugates, common denominator, all of that stuff. It's going to give you an easier way to do it. And then we're going to do something called linearization, which is all about tangent lines. It's going to be super easy. We're probably not even going to have a problem set for this unit. We're just going to go straight into a quiz because it's so short. Do you want a problem set?
No.
And say I didn't give one to you, right? No.
No.
Yeah. Have you heard? All right. So what I want to do, I have 4 questions for you to do. You have about 20 minutes to do them. I was lazy and only made one version. So good luck. Feel free to not help your neighbor if they've been sassy to you today. There are 2 questions that have to do with the 5.1 notes, so you may need those 2 rules. I can look them up on the board though. I am going to attempt to. They're going to be a little small. Oh, these are way too small. All right, well, I'll put the natural log one up. Or I'll do the A to the U. All right, you have almost 20 minutes to do 4 problems, so I expect it's done before you leave. You're going to turn it in whether it's done or not. I already have the first one done. Whee! Yeah.
The question asking for curves that can transform on your favorable
What?
a curve that can transform.
Like capital U, capital V?
It's lowercase u dash 4. I have no idea what it is.
Either. UV just makes me think of integration by parts, but that's because I just taught that relatively recently.
I looked it up too. I can't find it.
Whoa. Hey, how do you know? You don't have to school. You don't have to know.
What was that name? I don't know, I heard they're 80% European.
That was the European Actually, someone.
Oh, this is a hard one.
No.
If you need the rule for number 2, I don't know, it may be up on the board.
Yeah, really.
Okay.
It's fairly big. It's not even big enough to last. Did you know Texas is bigger than Alaska? Yes, it is. You get 1/7? No. Why? No. I got 10/8.
No, G prime.
Oh man, this was great.
Did I really make it that nice? What? Nope, I didn't. I don't know if it's that. Oh, y'all, 5 times 6 is not 10. Wow.
11. Obviously.
Wow.
I assume you just plug it in too. And then you pick that keyword, which would be. Am I
Oh,
right?
I'm so proud of what?
Right. For 2, I just plug in the X.
That'll give you a Y value.
Yeah, and then I have to take a derivative of it. Because it's 2. Wait, when I take the derivative, should I not keep it as 49?
What?
Like, should I, y is 49, but when I do y prime, do I do it when it's simplified to 49 or when it's 7 to the second?
Neither. When it's 7 to the x, do that derivative. Because you need an x in there. And then plug in your 2 afterwards.
Oh, so
Wait,
then
is number
it
2
would end
not
up
the
being
notes
the
we
same.
discussed?
It'd be x to the next.
Mm-hmm. It's from, what, mirror, 5.1, yeah.
Wait, what's happening? Why is it number 2 from the one we took today? Well, because it doesn't have.
7 to the x.
It's asking other stuff.
So that's
Oh.
not our sine, not our tangent, and
Okay.
it's not saying generic either. 7.
No, hang on.
Oh, I'm so proud of this new start. I'm doing these questions up by myself.
Something right. Yeah.
Now you get it? Oh, man, what? How's that change? That is just a normal derivative.
This is not, I didn't put the rule up on the board, that now for me. It's from last class.
Okay.
I don't like what school, are you gonna? Okay, can you use the rules that we learned? When it says 8, you're gonna write 7.
Okay, fine. Oh, we have
No, I don't remember that.
It's from last
So what
class.
about, what what is slow?
Yeah.
I don't know. But what about the LS?
It's okay. Use the number, it's gonna be gross.
You already have X in.
So your slope is gonna look gross for you. It's probably
So
gonna
this
have
is
enough
what
of
this
it.
is?
Oh, yeah. So I, like, you were cycling on the 2, right? So So limiter is supposed to be a number, so there shouldn't be an X in it. What can you put
So
on
this
it?
is this, put times two. So y minus. That's the.
Yep.
This? Look at the show.
So we don't know this one. So
Three is my favorite one.
literally just.
Mhm.
Wait, is it 10 to 7?
You and 3 are
If you want, this is the rule you need for number 2. If you want number 3, I can scroll down.
How? What is natural log of 7? Are we supposed to?
Is 3 also this
You
class?
can turn out 47 in your.
I can just leave natural log of 7, I don't have to like solve that.
Correct. That's a number.
But then don't I have to multiply by 7?
Yeah.
Oh man, I gotta rewrite the second part.
Yeah, your slope is gonna be now. It's gonna have enough.
I just got to set it. You're going. Yeah, I said that.
No,
We could do y.
Oh, yeah, it's one.
I can do 3.
Equals, that's the base.
That's what.
Right, so,
You don't have to
so we
solve
have the
that.
bottom.
I don't remember how to do 3.
Do you want me to scroll down for the rule?
Oh, is it on the same?
It is. It's on the back side.
It's the same thing.
It's got a chain, natural log, and just the other.
Oh, all it's doing right here is, I think it's or close to
This one?
another chain. So then, I think it's for this. Okay, so just so to it.
Yeah, you know what that's five.
And then
So- I don't know. Look at it.
so they change the chain. No, it's still
Yeah, so for this slope, you wanna make sure that you plug in the slope, it should be a number. The only thing with the problem is that X right there, what could be wrong. When you plug it in, just leave the natural and set it in. You'll probably have like a number. And then you put something for the Y one.
Is that the end?
For what?
Yeah, we
It's
all.
fine.
Okay, so I love your derivative. You have to do more with it though. So I wanna know.
Is the top?
I know, right?
Wait, Brian is 2.
Oh,
Because
it's
you do the derivatives to input.
We're over 50.
That's better.
So it's like your chain.
That's what it is here, but it's like a key.
Now, let's figure out what else you have, because it says find the value of X. So my time it should look like X equals. When your slope
You
is.
said this.
Yeah.
I'm like,
So that's a great idea. Let's see the word.
So we just said equal.
Or
Yeah.
That's what I'm saying.
So I have to get this one with it.
Yeah.
It's like,
What is the, yeah, what
Sorry.
is the-
so, yeah, y equals slope.
All right, you guys still have about 8 minutes to take your time.
Like the second derivative.
Like Y. Y minus Y1, how do I get Y1?
Do you have something that's not Y equal? Just make sure it's a number.
Yep, of course.
Miss Happy.
Miss Sutton.
Oh.
Oh, wait, sorry. Okay. You would need to be your final answer is X equals, so you're solving for X right now. I think I'm gonna find it after that.
I've already screwed
And you're gonna get the bad answer.
This is base 10, right?
That is base 10. You're missing enough water loss. It'll make sense. It'll last you. Like two. What I would do is just plug this guy and do your numbers. I would also do that in a separate.
Oh, wait, no, 8 over. Yeah, it's 4 and 4, yeah.
No, you use the rule. So how do I get to equal 6? So read, ready?
So I would not make it cut. Instead, think of a way, that is equal to might make it easier instead of like trying to put an order to equal this.
Oh, yeah. If I still get 4, I'm gonna be happy.
You're not going to get
Wait,
far. I made sure it wasn't a guess and check number.
Real art here. Who did it? Wait, 3?
All
We got
these
less
things,
time, right?
first it has to be a number, so instead of that.
Who?
Oh, you got 2, but I don't know what choice.
Yay, 3, my favorite one. Yep, that works.
Wait a minute.
Well, no, you want like,
Yep, that'll work. All right, if anyone's making it to number 3, I'm gonna put the rule you need up on the board.
I don't know the steps, so that's.
You gotta figure out what the base of your log is.
I will respond.
Little cross and cross. Don't try to do too much.
When should I plug
Don't
in,
distribute.
when should I plug in X at the last one, like at the beginning?
So after you take the derivative, I would not simplify anything, I would plug it in right away.
Okay.
Because usually simplifying with numbers is easier.
So I'll do like.
So I would put the 2 in right here,
So plug it in here.
because otherwise I have to 4 over top. So I put it in right there. You have the same thing on both sides, you see what divide by, and maybe it will go on this one. Hey,
Cool. I got it right.
you know what that means, well, you only have 5, this whole table is only 4 to 2.
So what are the steps after I?
All
What are the steps? after this?
right, so you have.
I don't have
All right, now I said that the slope is equal to.
So I have to set this,
Smart,
cross multiply?
good idea. All right,
Oh, that's a lot of multiplication.
it's not that bad.
I don't know what 6 times, is that just 6 times a lot?
Why don't you just cross multiply without simplifying first, and then see if anything good happens?
No,
Yeah. that's-
nothing
that's
good.
Or you say?
fine.
I'm gonna take.
Nothing good at all.
I'll just stick with 1 and 2.
Get it in.
Oh, wait, no, I still here.
Oh my God.
Are you
She's so talented, like, I don't even have to, like, sing that, she's so talented.
Cut it out, man.
1/2. I got X equals 1/2.
If I would look at that A, what is your base if I don't?
That would be detrimental to my grade. And oh golly god, what is that?
Otherwise, you're.
Are you serious?
Into the transfer size of that.
Don't pay attention. Yeah, I'm a kid. That's a good question. It still has three. I don't know why.
Why is it on top of it?
All right, before we leave, y'all, can I just have your quick attention?
Yes.
Perfect. All right, so looking at our calendar, I just want to give you guys, I know this is a little bit nasty looking. Here's us at 5.2. We're going to do 5.3 next time. That's going to be limits called L'Hopital, probably the kind of densest section that we're doing. 5.4 linearization is pretty darn short. And then we're looking at either a quiz. It's going to be more like quiz prep. It's not going to be a full test. Either the 15th or the 17th, depending on how we're doing. So just to kind of update you as you go. And then no more derivatives. Not ever, but for a while. For a while. And we get to stop talking about slope. We're going to stop talking about slope because I really was.
We forgot to
Now what was that?
All right, make sure I have your notes checked before you leave, even if it's not done. Okay, I'll get them back to you. And have a great day.
I need my Friday snack. I need my Friday snack. Where did I get our snack?
I think we need to.